Hello everyone. Today let's discuss about elementary graph operation. In this video, we are going to deal with the topics graph, types of graph, representation of a graph, operations on graph, traversal of graph, and at last applications of graph. First, let's see what is a graph. Graph is a nonlinear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges are lines or arcs that connect any two nodes in the graph. More formally, a graph is composed of sets of vertices and set of edges. The graph is denoted by G open bracket V, E closed bracket. Types of graph. There are two types of graph, undirected graph and directed graph. A graph in which edges do not have any direction, that is, the nodes are unordered pairs in the definition of every edge. Directed graph. A graph in which edge has direction, that is, the nodes are ordered pairs in the definition of every edge. In this image, we can see how directed and undirected graph looks. Next, representation of graph. There are two ways in which we can represent a graph. The first way is adjacency matrix representation of graph. In this method, the graph is stored in the form of 2D matrix where rows and columns denote vertices. Each entry in the matrix represents the weight of the edge between those vertices. Here we can see how adjacency matrix representation of a graph looks. The next way is adjacency list representation of graph. This graph is represented as a collection of linked lists. There is an array of pointer which points to the edges connected to that vertex. Here we can see how representation of a graph is done through adjacency list. Let's move on to operations on graph. The first operation is add or remove a vertex in a graph. The second operation is add or remove an edge between two vertices. The third operation is check if the graph contains a given value. The fourth operation is find the path from one vertex to another vertex.
Graph traversal in data structure. Graph traversal is visiting or updating each vertex in a graph. The order in which they visit the vertices classifies the traversal. There are two ways to implement a graph traversal. They are breadth first search. It is a traversal operation that horizontally traverses the graph. It traverses all the nodes at a single level before moving to the next level. It begins at the graph's root and traverses all the nodes at a single depth level before moving on the next level. So next is depth first search. This is another traversal operation that traverses the graph vertically. It starts with the root node of the graph and investigates each branch as far as feasible before backtracking. Now let's discuss applications of graph in data structure. It helps to define the flow of computation of software programs. It is used in a network such as Facebook and LinkedIn. Blockchains also use graphs, and it is also used in modeling data. As mentioned, there are multiple applications of graph in data structures. Hope you enjoy the video. Thank you.